Okay, so you want to own a data center, a giant windowless building humming quietly in the middle of nowhere, racks and racks of servers running around the clock, and every big tech company on Earth paying you rent just to keep their computers plugged in. No customers walking through the door, no inventory to manage, no seasonal swings, just pure, boring, recurring revenue. That's the pitch. That's what's driving one of the biggest waves of construction money in the world right now. Here's what the pitch leaves out. A single facility can cost more than a professional sports stadium. The power bill alone can rival a small city's, and the entire business depends on a handful of customers who can walk away the moment a better deal shows up down the road. By the end of this, you'll understand why data centers have become one of the hottest assets on the planet, and why owning one is nothing like owning a warehouse with better air conditioning. Before you pour a single slab of concrete, you need to understand what you're actually building, because data center covers several very different businesses. A hyperscale data center is the kind Amazon, Google, and Microsoft build for themselves, enormous campuses running exclusively their own cloud infrastructure. A colocation data center is a building you construct and then rent out in pieces, individual racks, or entire suites to other companies who bring their own servers. And a wholesale data center leases entire buildings or massive power blocks to a single tenant, often one of the big cloud providers themselves, on long-term contracts. These are not the same business. A hyperscaler builds for itself and never collects rent from anyone. A colocation operator is closer to a landlord managing hundreds of small tenants. A wholesale operator is closer to a landlord with one enormous tenant and one enormous risk if that tenant ever leaves. Land and power, the two things that decide everything. The first real cost isn't the building. It's finding a site with enough electricity available to run it, and that has become the single hardest constraint in the entire industry. A large data center campus can require anywhere from 100 megawatts to over a gigawatt of power, and utilities in popular markets like Northern Virginia now have multi-year waiting lists just to connect a new facility to the grid. Data center operators are increasingly signing power purchase agreements directly with utilities or even building their own on-site power generation, including striking deals for dedicated nuclear and gas capacity, just to guarantee they'll have electricity available by the time construction finishes. Land itself is comparatively cheap. A large parcel outside a metro area might run a few $1,000,000. The power interconnection agreement to actually use that land can take longer to secure and matter more to the project's value than the land itself. Now, the build. A modern hyperscale data center facility costs roughly $10 million to $15 million per megawatt of capacity to construct. Once you include the building shell, the electrical infrastructure, the cooling systems, and the server racks and networking equipment inside. A single 100 megawatt campus, a mid-sized facility by current standards, can run over $1 billion all in. The largest projects being announced now, multi-gigawatt AI training campuses, are being priced in the tens of billions of dollars for a single site. Microsoft, Google, Amazon, and Meta collectively are on pace to spend well over $300 billion in a single year on data center and AI infrastructure capital expenditure. That is not a typo. That is 4 companies spending more in 12 months than most countries spend on their entire annual infrastructure budget. Inside that build cost, the single biggest line item after the shell of the building itself is cooling. Servers generate enormous heat, and a data center that overheats doesn't slow down, it shuts down, sometimes destroying hardware in the process. Traditional facilities rely on massive air conditioning systems and chilled water loops. Newer, high-density AI facilities, packed with GPUs that draw far more power per rack than a typical server, increasingly require liquid cooling piped directly to the chips, because air alone can no longer keep up with the heat those processors generate. A rack of AI training hardware can draw more power than an entire rack did 5 years ago, sometimes 10 times more, and every one of those watts eventually has to be removed as heat. So how does a data center actually make money? For a colocation or wholesale operator, the model is deceptively simple on paper. You lease space, power, and cooling capacity to tenants, typically priced per kilowatt of committed power rather than per square foot, because power is the real constrained resource, not floor space. A tenant might sign a contract guaranteeing them 2 megawatts of capacity for 10 years, paying a fixed monthly rate whether they're using the full capacity or not. This is where the business starts to resemble a utility more than real estate. You're not just renting a room, you're renting guaranteed, redundant, always-on electrical and cooling capacity, backed by service-level agreements promising 99.99% uptime or better, because a few minutes of downtime for a major cloud tenant can cost them millions of dollars and cost you the contract. Here's the layer that makes data centers genuinely different from an office building or a warehouse. Redundancy isn't optional, it's the entire product. A Tier 3 or Tier 4 data center, the standard most serious tenants demand, requires duplicate duplicate power feeds, duplicate cooling systems, and battery and generator backup capable of running the entire facility for hours if the grid fails. You are essentially building two of everything because your tenants are running infrastructure that cannot go dark ever, and they are contractually holding you to that standard. This is why the operating cost of a data center looks nothing like a normal commercial building. Diesel generators sit idle for years, fully fueled and tested monthly, purely as insurance against a power failure that might never happen. That insurance isn't optional overhead. It's the reason a tenant signed the lease in the first place. The revenue side has one enormous advantage over almost every other real estate asset class: contract length. Data center leases with major cloud and AI tenants typically run 10 to 15 years, sometimes longer, with built-in rent escalations. This is dramatically longer than a typical office lease and far more predictable than a hotel or a mall. Once a hyperscaler moves in and connects thousands of servers, the switching cost of leaving is enormous. Physically relocating racks, migrating live workloads, renegotiating power agreements elsewhere. This is why data center operators can raise debt so easily against these facilities. A 15-year contract with a company like Microsoft or Amazon looks, to a lender, almost like a government bond with a building attached. But that same concentration is also the risk nobody likes to talk about at the pitch meeting. A meaningful share of leased data center capacity in the country sits with a handful of hyperscale tenants. If even one of them decides to slow its expansion, shift workloads to its own newly built facilities, or renegotiate a contract at renewal, the impact on a wholesale operator's revenue can be immediate and severe, because there often isn't a deep bench of replacement tenants who need that exact amount of power in that exact location. This is structurally similar to the anchor tenant risk that has crushed shopping malls for decades, except instead of losing one department store, you can lose an entire building's worth of committed revenue in a single contract decision. There's also a newer and stranger risk sitting underneath the current AI-driven building boom: obsolescence. The GPUs and specialized chips powering today's AI data centers are evolving so fast that hardware installed today can be functionally outdated within 2 to 3 years, pushing tenants to demand newer, more power-dense, liquid-cooled facilities rather than renewing into yesterday's design. A building engineered around 2023-era power and cooling assumptions may already be the wrong shape for 2027-era chips. Operators are now racing to build facilities flexible enough to be retrofitted for the next generation of hardware, because a data center that can't handle tomorrow's power density is a data center that starts losing tenants to whoever built next door with better cooling. Let's build a realistic scenario. A colocation operator builds a 50-megawatt facility for roughly $600 million, all in land, shell, power infrastructure, and cooling. They lease it out at a typical market rate, achieving strong occupancy with a mix of enterprise and cloud tenants on long-term contracts. Annual revenue from leased capacity, power pass-through, and connectivity fees might land around $110 million to $130 million a year once fully leased. Subtract operating costs, electricity purchased at wholesale, and partially passed through to tenants, staffing, maintenance, insurance, and property taxes. Roughly $40 million to $55 million a year. Subtract debt service on the construction cost, which for a project this size can easily run $35 million to $45 million annually. What's left is a genuinely healthy operating margin in a good year. Often the reason data center real estate investment trusts have traded at premium valuations compared to almost every other property type on the stock market. Now the bad year. A major tenant representing a fifth of the building's leased capacity declines to renew at contract expiration, choosing instead to build its own facility elsewhere. Replacing that tenant takes 18 months in a market where competing operators are simultaneously trying to lease up their own new capacity. During that vacancy, fixed costs, power infrastructure maintenance, security, staffing don't shrink just because part of the building sits idle. Meanwhile, a regional utility announces new interconnection delays are pushing the next planned expansion phase back by 2 years, freezing growth exactly when the operator needed new leasable capacity to offset the loss. The gap between those 2 years on the same asset can run into the tens of millions of dollars, and unlike a mall losing a department store, there's no foot traffic story to fall back on. There's only the power contract, the cooling capacity, and whether someone else needs exactly that much of both, in exactly that location, right now. That's the real shape of the business. A data center isn't really a building. It's a long-term bet that a small number of enormous companies will keep needing more electricity in more places for longer than it takes you to pay off the debt you took on to build it for them. When that bet is right, the returns are some of the most reliable in real estate. When it's wrong, you own the most expensive empty building in America, sitting on a power connection nobody else in the region is big enough to use.